In the vastness of the cosmos, where light takes billions of years to travel, a new discovery has sent shockwaves through the scientific community. The James Webb Space Telescope, humanity's most advanced window into the distant universe, has detected a colossal structure from nearly 12 billion years ago, one that challenges everything we thought we knew about the early cosmos. This discovery is more than just another deep space observation. It's a glimpse into an era when the universe was still in its infancy, forming the foundations of the galaxies we see today. For decades, scientists have pieced together a cosmic timeline, believing that structures of such immense scale couldn't exist so early in the universe's history. But now the James Webb Telescope has revealed a celestial phenomenon that defies those expectations. A massive interconnected assembly of galaxies and cosmic material stretching across the void of space. This isn't just another distant galaxy or a cluster of stars. It's something far bigger, an ancient web of cosmic proportions formed in an era when the universe was still less than 2 billion years old. To understand why this discovery is so groundbreaking, we need to look at the timeline of the universe itself. The Big Bang, the event that started it all, occurred approximately 13.8 billion years ago. In the first few 100 million years, the cosmos was a chaotic mix of energy and particles, slowly cooling and expanding. During this time, the first stars ignited, and the earliest galaxies began to take shape. However, these galaxies were expected to be small and scattered, only later merging into larger structures over billions of years. This new discovery, however, suggests that something far larger was already taking shape, just a fraction of the universe's current age. The structure detected by James Webb appears to be an enormous cosmic web of galaxies, stretching across space at a scale that shouldn't have been possible so early. It challenges the standard model of cosmology, forcing scientists to reconsider how quickly the universe was able to organize itself into large-scale formations. This vast structure isn't just an ordinary galactic cluster. It's something known as a large-scale structure, a fundamental building block of the cosmos. These massive formations include galaxy filaments, superclusters, and cosmic voids, all woven together by the invisible force of gravity. The problem? Standard models predicted that such massive structures wouldn't have had enough time to form so soon after the Big Bang. But now, Webb's observations suggest that the universe may have been evolving at a much faster rate than we previously believed. One of the most striking aspects of this discovery is how well hidden this structure was. Even the Hubble Space Telescope, which has been peering deep into the universe for decades, never detected anything like this. The reason? Hubble, while powerful, primarily observes the universe in visible light. The James Webb Telescope, on the other hand, is optimized for infrared observations, allowing it to peer through cosmic dust and see further back in time than any telescope before it. Infrared light is crucial when looking at the early universe because as light travels across vast cosmic distances, it gets stretched by the expansion of the universe. This effect, known as redshift, means that the oldest and most distant structures are best observed in infrared wavelengths, exactly where Webb excels. This ability has allowed astronomers to detect not just individual galaxies, but an entire network of cosmic material stretching across space in a way that had never been seen before. But what exactly is this structure? Scientists believe it could be a protocluster, a massive assembly of young galaxies in the process of forming a supercluster. Superclusters are among the largest known structures in the universe, containing thousands of galaxies bound together by gravity. If this structure truly is an ancient protocluster, it could be one of the earliest examples of such formations ever detected, offering new insights into how galaxies and cosmic structures evolved in the early universe. The implications of this discovery are profound. If structures of this size existed so early in the universe, It suggests that galaxy formation and cosmic evolution were occurring far more rapidly than expected. This could mean that our current models of how galaxies formed and merged need significant revision. Scientists may need to rethink the role of dark matter and dark energy in shaping the universe, as these mysterious forces play a crucial role in cosmic evolution. Dark matter, an invisible substance that makes up a significant portion of the universe's mass, is believed to act as the cosmic scaffolding upon which galaxies form. If this newly discovered structure formed earlier than expected, it could suggest that dark matter was clumping together much faster than previously thought, pulling galaxies into massive formations sooner than our models predicted. This would require adjustments to our understanding of how dark matter interacts with ordinary matter and gravity on a cosmic scale. But the mysteries don't end there. Alongside this structure, Webb has also detected an unusually high number of bright, massive galaxies in the same region, galaxies that, according to existing models, shouldn't have had enough time to grow so large. These galaxies appear to be packed with stars far older than they should be, suggesting either a much more rapid star formation process or the possibility that some of these stars could be remnants of an even earlier cosmic era. This discovery also ties into another growing mystery: the existence of ancient red dust-covered galaxies that Webb has been spotting across the cosmos. These galaxies are unusually massive for their age and appear far more developed than expected. Could it be that galaxies in the early universe were forming and evolving at an accelerated rate? If so, what does that tell us about the fundamental forces driving cosmic evolution? The James Webb Space Telescope is providing answers, but also raising more questions than ever before. As astronomers continue to analyze this colossal structure, new observations could further challenge our understanding of the early universe. Future studies will focus on measuring the exact distances of these galaxies, their chemical compositions, and how they fit into the larger cosmic web. And this is just the beginning. Webb has already proven that the early universe was far more complex than we ever imagined. If a structure of this scale existed just 1.8 billion years after the Big Bang, what else is out there, hidden beyond the reach of our telescopes? Could there be even larger, older formations waiting to be discovered? This discovery reminds us that the universe still holds countless secrets waiting to be unveiled. With each new observation, we're not just looking back in time, we're rewriting the very history of the cosmos. The James Webb Space Telescope is proving to be one of the greatest scientific tools ever built, and as we continue to explore the distant reaches of space, there's no telling what other surprises await us. The discovery of this 12-billion-year-old massive structure not only reshapes our understanding of cosmic evolution, but also raises fundamental questions about the forces driving the formation of the universe. If such vast networks of galaxies were already forming so soon after the Big Bang, then our models of cosmic expansion, dark matter, and galaxy evolution might need to be significantly revised. One of the most surprising aspects of this discovery is that it suggests that gravity, the force responsible for pulling matter together, may have been acting in a much more efficient or accelerated manner in the early universe. The standard cosmological model predicts that galaxies formed slowly over billions of years, gradually clustering together to form larger structures like the ones we see today. However, if this newly detected structure was already taking shape just 1.8 billion years after the Big Bang, then some unknown factor may have sped up the process of cosmic assembly. One possibility is that dark matter, the mysterious, invisible substance that makes up roughly 85% of the universe's total matter, was behaving differently in the early universe than it does today. Dark matter plays a crucial role in shaping the large-scale structure of the cosmos, acting as a kind of cosmic glue that helps galaxies come together and form clusters. If this massive structure formed so early, it might indicate that dark matter clumped together more quickly than current models predict. Another possibility is that cosmic inflation, the rapid expansion of the universe in its earliest moments, may have left behind fluctuations in the fabric of space-time that created large-scale structures earlier than we expected. If this were the case, it would mean that some regions of the young universe had an unusually high concentration of matter, allowing galaxies to form and cluster together at an accelerated rate. This discovery also raises questions about the role of supermassive black holes in shaping the early universe. Scientists have long known that black holes, particularly the supermassive ones at the centers of galaxies, play a crucial role in galaxy evolution. Their immense gravitational pull can regulate star formation by either fueling rapid growth or suppressing it by ejecting vast amounts of energy and gas. If this massive 12-billion-year-old structure contained multiple active black holes, it could help explain why so many bright massive galaxies have been found in this region. Recent observations by the James Webb Space Telescope have already hinted at an unusual number of ancient quasars, extremely bright, active galactic nuclei powered by supermassive black holes, lurking in the early universe. These quasars release enormous amounts of energy, potentially influencing the growth of galaxies around them. If this newly detected structure is home to a large number of quasars, it might mean that black holes played a much larger role in the formation of massive cosmic structures than we previously believed. Another intriguing question that arises from this discovery is, could there be even larger structures that we have yet to detect? The James Webb Telescope is only beginning its deep space exploration, and every new observation seems to challenge existing models of the universe. If a massive structure like this can exist just 1.8 billion years after the Big Bang, then it's possible that even grander cosmic formations are hidden deeper in space, waiting to be discovered. One way to investigate this further is by looking at the distribution of galaxies within this structure. Are they arranged in a way that suggests a filament-like cosmic web, similar to how galaxies are structured in the modern universe? Or is this a fundamentally different type of formation, unlike anything we've seen before? The detailed mapping of this structure, using both Webb and other telescopes, will be crucial in answering these questions. Additionally, studying the chemical composition of these galaxies could provide further clues about how they formed. The elements present in a galaxy's stars can reveal insights into how many generations of stars have lived and died within it. If these galaxies contain high concentrations of heavy elements like carbon, oxygen, and iron, it could indicate that they went through multiple cycles of star formation much faster than expected. On the other hand, if they mostly contain lighter elements like hydrogen and helium, it could suggest that we're looking at some of the first galaxies ever formed, which somehow managed to cluster together far sooner than models predict. Either scenario would be groundbreaking, offering unprecedented insights into the physics of the early universe. One particularly exciting aspect of this discovery is that it aligns with several other surprising findings made by the James Webb Space Telescope. Over the past year, Webb has detected a growing number of massive, well-formed galaxies that seem to have appeared too early in cosmic history. These galaxies are far larger and more evolved than they should be, given how young the universe was at the time. Some scientists have even proposed that we might need to reconsider aspects of the standard model of cosmology, including the role of dark energy, the mysterious force that is driving the accelerated expansion of the universe. If structures like this massive 12-billion-year-old formation turn out to be more common than expected, it might suggest that the early universe was expanding and evolving differently than our models predict. Of course, before making any radical changes to our understanding of cosmology, scientists need to gather more data. Follow-up observations with Webb, as well as other telescopes like the upcoming Nancy Grace Roman Space Telescope, will be crucial in confirming the true nature of this structure. Future research will focus on measuring the exact distances and redshifts of the galaxies within this massive structure to determine how they are interacting. By studying the movement of these galaxies, astronomers can gain insight into how the structure is evolving and whether it will eventually form a supercluster. This discovery also has profound implications for our search for the earliest galaxies and potentially even the first stars. If structures of this scale existed so early, it might mean that the first generation of stars, known as population 3 stars, formed and died much earlier than we expected. These stars, made almost entirely of hydrogen and helium, are believed to be the very first sources of light in the universe, kickstarting the process of galaxy formation. Could it be that population 3 stars played a role in rapidly assembling this massive structure? If so, studying this region of space could give us our best chance yet to uncover direct evidence of these ancient stars. One thing is certain: the James Webb Space Telescope has fundamentally changed our view of the cosmos. Every new discovery it makes is challenging what we thought we knew about the early universe, and this massive 12-billion-year-old structure is perhaps the most stunning example yet. We are standing at the edge of a new era in astronomy, one where our understanding of the universe is being rewritten with each new observation. What other surprises lie hidden in the depths of space? And what mysteries will Webb uncover next? One discovery has already changed everything, and the universe is just getting started.